Hello everyone, and welcome to this next troubleshooting video for the ASA, released by the Cisco Tax Security Podcast team. My name is Jay Johnston, and today we're going to talk through troubleshooting another problem with this lab scenario here. We have users on the outside of our 3-interface firewall that are trying to access a web server that's on the inside. This is a 3-interface firewall. We've got inside, outside, and DMZ. And at this point, the users on the outside cannot connect to the web server that's on the inside interface. And those users are directly trying to access the web server's real IP address. There's not any NAT being done in this scenario. So those users cannot bring up that page. So here we are. We're on our Pod 6 firewall. This is an ASA 5505 with 512 megs of RAM, running version 9.1.2. Again, the version really doesn't matter that much. These same troubleshooting tools that we're going to use today are applicable and available on most ASA versions. So if you've got a Firepower 9300 with an ASA with 72 CPU cores, you can use these same tools to troubleshoot that problem. So the first thing I would do is just verify these packets are coming into the outside interface. If users claim that they're trying to access something through the firewall, a lot of times people blame the firewall for dropping packets when the packets never even reach it. So let's double check that. We're going to use a capture with the match command. So I'll say capture outside interface outside match. This is TCP from any to host 10.3.6.50 on port 80. So let's capture traffic just destined to the web server on just TCP port 80. If I do a show cap, I can see, yep, I'm capturing traffic. So if I do show capture outside to see the details, okay, here are our packets. We can see packets sourced from 10.1.1.211, which is actually a client that's constantly trying to connect every 5 seconds or so, trying to reach that web server on port 80. It's sending a SYN packet and not getting anything back. And then it tries again 5 seconds later. You can tell that from the timestamps. So this is our problem. We're not getting any response. And we know the packet's entering the outside of the firewall. Let's check to see if it's leaving the inside. I'll just make another capture here. And it's important not to apply the same capture to two different interfaces. That gets really confusing. So go ahead and just do one capture on the inside, one capture on the outside. You should be done. So let's do show capture. And I'll go ahead and clear all of these out. It's clear cap/all to clear them all out at the same time. Run show capture and wait for my packets to come in. And there we are. I saw the SYN packet enter the outside interface and nothing egress the inside. So it is indeed our ASA that is dropping this traffic. So the next thing to do is to check our syslogs. So I'll do a show run log, see if these are turned on. Their logging is turned on, but it's not fully configured, so I'm going to log to the local buffer at debug level. Let's do a show con to see how many cons I have. I only have 8 in use. I mean, this is not a big deal, so I'm not going to overrun my buffer too quickly. So I'll go into config mode, say logging on, it was already turned on, logging buffered debug. Okay. Drop out of config mode and type show log, and I should start to see some packets. And right away I can see ASA syslog 106023 deny TCP source outside. That's our outside host. Okay. Destination inside by access group outside in. Interesting. So the strange thing about this is that if I look at the packet on the outside, and some of you may have caught it already. If I look at the packet on the outside, the packet is sourced from 10.1.1.211, yep, destined to 10.3.6.50, which is the IP address 10.3.6.50 in our web server, right? But if I go up to the syslog, it says it was denied destined to inside 192.168.32.50. Okay, that's strange, because that's not the packet that was actually on the wire. If I take a look at the log again, I can see here, in fact, this continues to repeatedly happen. There's traffic destined to the web server's real IP address, but the syslogs are claiming that the packet was denied and destined to some other address. Okay, so the question is, how can that happen? Well, the feature on the ASA, just like any other firewall that supports it, that will change the IP addresses and packets, is the NAT feature. So what I'm guessing is going on is that there is some NAT command that is natting the traffic before the access list takes place. And for those of you who know, in version 8.3 and later in the ASA software, you define access lists on your outside interface, permitting traffic to the real or unnatted IP address of your server on the inside. There's a lot of really good reasons why we do this now. I won't go into them in this video, but rest assured that the NAT untranslate phase happens before the ACL check. So some piece of the config is must be translating this packet before the access list fails, right? The check goes against the outside access list and it fails. So one way, if you think this is the case, one way to see that is to do, you could go through the whole NAT config, but that's hard to do, and it's it's hard for a human to look at that output and try to unwind what the NAT policies will do. If I do show NAT, it'll give me some good information. This will be the actual NAT table of the ASA. Better yet, if I do show NAT detail, this will show me the NAT policy with the objects exposed and their real IP addresses shown. So what this lets me do is view the NAT policy table as defined by the configuration, and it'll show me not just the NAT rules, but then the source and how the destinations and sources get translated in the packet, which is really nice. So it not only shows me the real IP addresses of the objects, but also the translate and untranslate hits. That's what you see here. So a translate hit is the number of times a new flow was created that matched that NAT rule in the forward direction, meaning that since this NAT rule here is defined from DMZ to outside, if a new flow was created from DMZ to outside and it matched this NAT rule, then we would increment the translate hits by 1. And then subsequent packets that match that same connection would not increment it because we've already evaluated the NAT table, right? The XLate is built. So this is the number of new connections or new flows that were matched the NAT rule. The untranslate hits would be a new connection built in the reverse direction. So a new connection that matched this NAT rule from outside to DMZ. So what I'm looking for here is, it looks like I have several NAT rules on this ASA that don't have any translate or untranslate hits. So if my packets to my web server are being translated, then there probably is a translate or an untranslate hit for a NAT rule that it must be matching. So I need to make sure that that NAT rule looks correct. And so if I just scroll down here and keep going through my rules, it looks like I've found it. Position number 13 in the table, it says there's a NAT rule here from inside to outside, and it says something about object wireless users to object wireless users global, and I can see the untranslate hits is 164. So this is probably my traffic. This is a contrived lab example, but the packets are matching this NAT translation, and I can see that the problem is that on the outside interface, where this NAT translation, that's the global interface for this NAT translation, the global object, or the global NAT range, is 10.3.6.0/25. So this is a misconfiguration. This is an overlap. And my inbound traffic to my web server is matching this NAT rule, getting untranslated to the 192.168.32.x network, and then dropped by the access list because we're not explicitly permitting traffic to 192.168.32.x. The rule below it, rule number 14, this is actually the NAT rule I wanted, right? That I wanted to take action on this traffic. So this is just a misconfiguration. We see this come up. On the ASA, most NAT problems come down to NAT rules in the wrong order, if you're doing manual NAT, where you can specify the order of the NAT rules, or you're using object NAT and there's an overlap in the networks, or the rules are too broad. So you've got objects that are really, really broad in scope. And if that happens, you can have a problem like this, where your NAT rules match traffic that you don't think they should, but actually they do. So that's the problem. Another way I could have found this problem is with Packet Tracer. That would have led me to the problem right away, but for this video I wanted to walk you through some of the other steps. So I'll do that. Packet Tracer input outside TCP 10.1.1.211, give it a fake port, source port, destined to 10.3.6.50 on port 80. If I run this, it'll create a simulated packet injected into the receive ring on the outside interface and walk me through what the ASA does with it, so I can see it hit my capture. Pretty cool. Layer 2, low-level access list, and then right away you can see the unnat phase. Again, the unnat phase happens before access list, which is down below, and it says, it shows me the actual config. It says NAT divert to egress interface inside, and untranslate the destination from 10.3.6.50 to 192.168.32.50. This is my problem. So to fix this problem, I'm just going to remove that rule. No object network, object wireless users, and hopefully that does it. Now if I run that packet tracer again, let's see what happens. Yep, I'm matching the NAT rule I would expect to hit, and my ACL is permitting the traffic. And at the very end, it'll say action allow. So this is good. And I'll do show NAT detail just to double check. And you can see here that, yes, I've got 5 untranslate hits on the NAT rule I expected to be hitting on, and that works good. Let's look at the logs, just to verify that my connections are being built and torn down successfully. And I can see here, yep, built inbound TCP connection from outside to inside, teardown TCP connection from outside to inside. And the teardown reason was TCP fins, and I transferred about 2.7K of data. So that's it. This was a fairly common problem that we see in the TAC, whereby the NAT rules are out of order. In this case, these auto NAT rules were overlapping because someone had put in the incorrect global object in a NAT statement. Removing that object fixed it. We could have also changed the global address range that NAT rule used, and that would have caused this traffic not to overlap as well. So we used packet tracer, packet capture, syslogs, fix the config, and so yeah, that's how we troubleshot this NAT problem. All right, hope you learned something. Till next time.